Alright, let's provide some clarity on what a vector 4 is and what it is typically used for. Alright, hello everyone and welcome. In today's video we're going to go over what a vector 4 is, and of course we're going to cover a bit on 2D and 3D here on its explanation, so hopefully you can have a fairly decent understanding going forward in case vector 4 ever comes up in the future. Now, a vector 4 is a data type, much like our vector 2 and vector 3. And this is a container, and it holds 4 pieces of information, just as a vector 2 holds 2 pieces, an x and y. And a vector 3 holds an x, y, and z, or x, y, and z. Now, depending on what you're doing, these 4 pieces of information can represent completely different things, which makes sense. If we're using a vector 3, we could just be holding 3 different numbers. Or if we're looking at it in terms of a position, then we're using that x, y, and z here inside of 3D space for its vertical, horizontal, and depth placement within the world. So in 3D graphics, a vector 4 is used to represent the position and orientation of objects in 3D space, along with the value of the homogeneous coordinate, which is what we call the 4th number in there, which is represented with a W. So we have X, Y, Z, and W. The X, Y, and Z component of the vector represents the object's position in 3D space. So we have, again, our left and right here with our X, our up and down with our Y, and then our Z giving us that perception of forward and back. While the W component, or again the homogeneous coordinate, is used to help with calculations related to things like rotation and scaling. Now, an example here would be if you were to create a 3D game, you might use a vector 4 to represent the position and orientation of the player character. You could use the X, Y, and Z components to represent the character's position in 3D space, and the W component to help with calculations related to things like the character's size and the camera perspective. Now, when it comes to shaders in 3D graphics, shaders can be used to manipulate how objects in the 3D space are displayed on screen. 3D shader can take in a vector 4 data type as input and use them to perform a variety of calculations that ultimately affect how an object is displayed on the screen. For example, a shader might use a vector 4 to represent the color of a pixel on the screen and use that color value in a calculation to create a special effect, such as a glow or a blur, or in terms of 2D, an outline, like we did a video, maybe 2 videos ago now. Now, in 2D graphics, in 2D graphics, a vector 4 is used to represent the position point in a 2D space along the value of the homogeneous coordinate, or along with the value of that coordinate. And as we know, the X and Y is going to be our left and right, and our up and down, right? Our horizontal and vertical here. And this represents, of course, the position on the screen, or our sprite in this case. While the W component is used to help with calculations related to things like texture mapping and transparency. And that's where it comes in with our shader, knowing whether we're drawing the outline that we want there, or if we're just leaving it as an empty space in the background based off of that transparency level. Now, for example, if you're creating a 2D game, you might use a vector 4 to represent the position of the player character on the screen, and you could use the X and Y to represent the character's position, and the W component to help the calculations related to things like transparency and your special effects. in 2D graphics, shaders can also be used to manipulate the appearance of objects on the screen, like our outline and the black and white that we've used before. A 2D shader can take in the vector-4 data type as an input and use them to perform the calculations on how the object is displayed, just like with 3D. So, for example, a shader might use a vector-4 to represent the color of a pixel. Can we get a pixel on here? There we go. We have our little pixels all in there, but we can use it to represent the color of a pixel on the screen and use that color value in a calculation to create that special effect, like the glow or blur. Alright, so hopefully that sheds a bit of light on that topic of vector-4. It basically just holds 4 datas, or 4, what did we use earlier? A container that holds 4 pieces of information. And if you've messed with colors, then you may have already messed with something just like a vector-4, not even have known it. I'm just going to go ahead and just save the scene. We'll put it in a new folder. Delete. Alright, just stick it in there. Whatever, same thing in there with that one. And if you messed with colors, if you've done, you might have come in and did the hex code, or you might have just done color dot, and then something like red, right? One of your colors here. And that would be perfectly fine. However, if you want a more of a custom color, then you're going to have some number here, right? So we have 1, another 1, whoops, just go like that. Right, so we have that, so that's our RGB, right? And that would be like a vector-3, our red, green, and blue. But as you see, we can put in a 4th variable here, or a 4th piece of data, and that is our alpha, which is going to be how transparent this object is going to be. So I'm just going to pull the blue out here, so we can actually see a visual change here. And if we run the scene, and just give me a moment to make sure that you can actually see what's going on here, and you can. Awesome. So you see we got a purple, and we are perfectly visible with that. But if we were to pass in something like 0.1, then we're only going to have a 10% visibility going on here, as you can see there. So if you've messed with colors in script, then you've kind of already played with vector-4s without knowing it. It's just, in terms of color, it's serving a specific focus. Whereas when we're using vector-4 data types in something like a shader, we're usually using it to perform some type of calculation to get a desired effect on the screen. Alright, hopefully that clears up vector-4s a little bit and gives you an idea of what they are and how they are typically used in programming here. And with that, take care. I'll see you guys in the next one. And if there's things that you guys want to see, go ahead and leave them in a comment below. And maybe we'll do that in the next video or two.